Swayam Prabha. Digital India. Educated India.
Welcome you all to the next class on inorganic chemistry of life principles and perspectives. So, we were looking at the mercury reduction from mercury 2 plus to mercury 0 by an enzyme called mercury reductase, and in fact this is the kind of the microorganisms which will act on the removal of the mercury from the environment. So, therefore, this is what we looked at in the previous class. Now, let us look at some non-conventional ways of the metalloenzymes. Now, we cannot use the word metalloenzyme, but it is a metalloenzyme in a common sense, in a common category. So, it is called based on the selenium. So, let us look at the enzymes based on the selenium. So, before we go into that, let us look at the selenium is in fact is first discovered by Johannes Jakob Berzelius in 1817, and it's named on the Greek goddess of moon Selene. So, therefore, the name comes from the term Selene, and it is one of the least abundant essential trace elements, as you would have seen the earlier what I gave long ago in the early classes about the concentrations of these and their presence in the human system, etc. And this is present in the, of course, in the P block element with the period 4 and group 16, and so most of the common ways that the selenium is present, unlike the metals like iron, cobalt, nickel, they are either directly attached to the protein side chains, or they are attached to some special compartments, etc. Whereas selenium is not like that. Selenium is basically involved as a part of the amino acid, like for example, the cysteine SH, instead of sulfur you will have a selenium. So, the only way that you find the selenium is this is referred as selenocysteine. So, this is basically in the form of a selenocysteine. So, it is not like a metalloenzymes. So, it is with this. So, the selenium is present as the selenocysteine, and it is an essential component of a number of enzymes, particularly that are the glutathione peroxidase. So, what is glutathione peroxidase? Glutathione peroxidase is an enzyme which is basically plays a role of removing radicals, toxic species. So, therefore, you can call it as an antioxidant enzyme. Okay. So, basically the cells are living on the oxygen, therefore, oxygen rich portion in the cells would tend to convert the inert oxygen to various 1 electron reduced species called superoxide, 2 electron reduced species called peroxides, and a broken species like hydroxyl radicals. So, a number of radical or active or reactive type of species are possible. So, these are called reactive oxygen species, as I mentioned earlier too. So, these are reactive oxygen species. So, all of these species are dangerous to the tissue, and so removing all this means acting as an antioxidant. So, therefore, the glutathione peroxidase enzyme acts like an antioxidant because it can remove all this. Okay, so in all these cases, the selenium part is basically selenocysteine is a cofactor for the activation and deactivation of a number of thyroid hormones and some of their metabolites, etc. Okay. Another aspect you will find in the sequence of these selenocysteine things is the thioredoxin reductase. So, thioredoxin reductase is an enzyme which uses a cysteine selenocysteine pair. So, cysteine selenocysteine pair is nothing but this one. So, this is cysteine selenocysteine pair, and this is from the thioredoxin or reductase. Okay. So, this is the kind of a bond which will reduce the disulfide bond in the thioredoxin part of it. Okay. So, therefore, the main role of the selenium in these enzymes is not like the conventional metal ions to form a metalloenzyme, but rather take up the position of the sulfur in the selenocysteine and involve in a number of enzymes including glutathione peroxidase. Now, what happens, this is, as I said, micronutrient, but very important nutrient, and its deficiency, its excess, I have already mentioned earlier, but let me bring back those things again. So, that means the concentration of the selenium must be maintained in the body in order to perform the biological functions in a proper way. Suppose if the selenium concentration is low levels, then the growth retardation is possible, cataract kind of things are possible. This is a Cash-and-Beck disease. So, Cash-and-Beck disease is nothing but the kind of the bone shrinking kind of a problems. So, muscle inflammation, enhanced skin pallor. So, because of this kind of things, you could see that the person looks at all these joints etc. with this the bone, and basically everything shrinks kind of a situation. So, there is a lot of problems of the deficiency of selenium. If you have selenium excess is also problem. So, excess selenium is toxic and less selenium is deficient. It shows the deficient syndromes, toxic syndromes, the hair loss, nail problems, fatigue, neurological, all kinds of things, breath. So, several of these things are there. So, therefore, the selenium is an important micronutrient, and it can be obtained from various food materials, foodstuffs like tuna fish, cheese, chicken, mushrooms, sunflower seed, etc., etc. So, many of these things have got good levels of selenium. So, therefore, these, by eating these, you will be able to get the selenium part of it. So, what I was telling is that there is radicals which can which are generated in the body because of the oxidative reactions happening, and therefore, unless these radicals are reduced, the tissue gets damaged. So, that is where you require the antioxidant kind of a property. So, the need of the need of the selenium enzyme is very essential. The free radicals can act on codons, they can act on cell mutation, they can act on cancer cells, they can act on organs and infect them, they can damage the organs, it can even lead to the death of it. So, therefore, free radicals are very dangerous, and therefore, these free radicals have to be removed by a system, and in our systems the selenium based enzymes do take care of these ones. So, we have already studied at a couple of stages at the manganese, at the iron, at the copper, zinc, etc., the superoxide dismutase. What does superoxide dismutase do? Superoxide dismutase converts the O2 minus dot radicals into H2O2, and the H2O2 is further removed or disintegrated or disproportionated by a popular enzyme called catalase that we have seen. And if not, the metal ions present in the body like transition metal ions, particularly iron, these kind of things, even copper, some of these things can convert this into a hydroxy radical, and therefore, this is a kind of a reaction is called the Fenton reaction. So, the hydroxy radical is much more dangerous than even the H2O2. So, therefore, it has to be removed. So, one of the method is by catalase, other is by the glutathione peroxidase. So, you have both of these are involved. So, the SOD is for the superoxide dismutase, and catalase is for the H2O2 disproportionation. So, and glutathione peroxidase also converts the H2O2 into water. So, these act, for example, here the thioredoxin R is also involved in such kind of a removal. Okay. So, the cofactors such as the PRX reduced will go to the PRX oxidized, and that will bring the thioredoxin reductase into the oxidized form, and then this will act on the TR2. So, this will also remove the H2O2 into water. And the glutathione peroxidase again, glutathione peroxidase in the reduced state will act on the H2O2 and go to its oxidized form, and this is being reproduced, and then that reduction will lead to the water, and the reduced GPXR is regained back to the oxidized GPX is brought back to the reduced one by using GSH to GSSG cycle. So, GSH to GSSG cycle will bring back the glutathione peroxidase oxidized to the glutathione peroxidase reduced form of it. That means cycle can work. So, the cycle can work when it couples with the GSH. GSSG is glutathione oxidized form. So, two glutathions joining together through sulfhydryl functions and forming a disulfide bond. So, the SOD is for the removing the superoxide, and the catalase and glutathione peroxidase is and the TRX reductase. These are all the enzymes which will convert the H2O2 into water. Okay. We have already studied the catalase part when we were in the manganese story. Now, we will study the glutathione part of it as a glutathione peroxidase. So, let us look at the glutathione peroxidase. Why is the name glutathione peroxidase? Glutathione peroxidase is because the peroxide is being decomposed, that is peroxidase. Glutathione will bring it back to the normal, therefore, it is a glutathione peroxidase. Now, the same thing what I talked can be seen like in the form of a schematic representation, and here you have, let us say, H2O2 and H2O2, the TRX reduced, thioredoxin reduced will oxidize and reduce this one to water, and the oxidized TRX is brought back to the reduced by an enzyme called TRX reductase, and this TRX reductase in turn takes help of NADPH. Okay. So, finally, it is the NADPH. So, NADPH to TRXR to the oxidized TRX, and that is one cycle. Okay. Other cycle is glutathione peroxidase. Glutathione peroxidase again acts on H2O2 and reduces to give the H2O, and this is regenerated by the GSH GSSG cycle, okay, and that is glutathione, you can call it as a glutathione reductase, and this is also helped by the NADPH. Okay. So, therefore, glutathione peroxidase and this part is called glutathione reductase. Thioredoxin peroxidase, thioredoxin reductase. Okay. So, these are all how the things are. So, as I have repeated to you several times, I am sure you will be able to understand without any difficulty in this. Now, let us come to the for a while glutathione peroxidase. So, glutathione peroxidase is also not just one simple enzyme like that of the cytochromes. You have huge family like even catalases or any other reductases, it is a family. So, family of enzymes which exhibit peroxidase like activity. So, it catalyzes the hydroperoxide or hydroperoxide based radicals, all these kinds of things which are very reactive to their corresponding alcohols, and by converting into alcohol, now the danger has been reduced and it protects the oxidative damage. Let's take an example here, glutathione simple acting on the R2O2. This is R2O2 is what? Peroxide. It can be alkyl peroxide or any kind of thing. If it is both or is equal to H, it will be hydrogen peroxide, and that will lead to the oxidized form of GSH, which is GSSG. So, SS you can see the bond, and this is the disulfide bond, and leads to the alcohol. So, GSH is a reduced form of the glutathione as a monomer. GSSG is oxidized form of glutathione disulfide, which is a kind of a dimer, but not a simple dimer, but it forms a bond between the two sulfur centers and the protons are lost. Okay. So, now you understand the glutathione. So, how does this glutathione peroxidase function? So, glutathione peroxidase, how it functions, then you see that selenocysteine we are talking about, and SEH we call, also it can be called as a selenol, just like SH is thiol, SH is thiol, SEH is selenol. So, this is not a difficult thing to understand. So, you have SH, you call it as a thiol, and SEH you call it as a selenol. Okay, thiol and selenol. Okay, now this reaction, the selenocysteine on this acts on the this selenocysteine is not a free simple amino acid. We are talking about in the enzyme, and this acts on the H2O2 and initially gets the oxidized to SeOH, and this is selenic acid. So, this is the selenic acid. So, if you make Se into OH, this is selenic acid. So, thiol, selenol, selenic acid. So, and this selenic acid further reacts with the glutathione, and an exchange will happen. So, the GS with SER, and loses the water. Okay. So, it is basically a kind of a condensation reaction into this. So, because this is acid and selenol, and here this OH, and this will act like acid, this will act like the base. So, therefore, you lose the water from here, and then H plus, and then here the OH minus, both together will go as water, and then you get GSSER. So, it is like a kind of a disulfide, but one of them is sulfur based, other is selenium. So, seleno versus thio, kind of a disulfide form. Okay, this kind of a selenium sulfur disulfide bond further reduced by GSH, glutathione, to form the GSSG and or SEH. Getting back to the enzyme is relieved here. So, it is basically enzymatic reaction, and the step 1, as you can see, that the selenocysteine pod will be reacting with the H2O2, and the product of the selenic acid will react with 1 mole of GSH and to form a SSE kind of a dimer or oxidized dimer, and this in turn again reacts with the GSH. GSH can reduce this one, therefore, you form GSSG kind of thing and or SEH. So, you have all the things are present in this. Now, look at this particular cycle, which will tell you the connectivity between the GPH, between the selenium, and this is part of the vitamin E, the selenium, and with that of the vitamin E. So, the selenium center, the lipid peroxides will always damage, okay, and this will convert selenium into hydroxy acids, to oxidation, etc., and here the membrane disintegration will happen because you are using the lipid peroxidation of the lipid. And on this side, which is more important to us, not so much important this part of it, but this is part is important. When the selenium acts on this, and this is being coupled with the glutathione going to the oxidized form of the glutathione, which is called GSSG. And this GSSG going back to the glutathione is activated by the NADPH going to the NAD plus. Okay. So, this part is called basically the glutathione reductase part. Okay. So, all these cases that works. Now, you have thioredoxin reductase also. So, as I have talked to you earlier, there are two parts there. So, this is the thioredoxin reductase, and this is glutathione peroxidase in that glutathione reductase. Okay. So, now let us look at for a while this thioredoxin reductase, which is called the TRXR. This is referred as TRXR, that is thioredoxin reductase. Okay, T or X, this is thioredox and or reductase. So, this will be thioredoxin, and then you have the thioredoxin. So, thioredoxin is referred as TRX, and this is referred as TRXR. And so, what will it do? The TRXR is thioredoxin reductase will reduce the disulfide bond present in the thioredoxin, and that will be coupled to the protein, and the protein disulfide in turn is broken. And therefore, this TRXR has got one of the cysteine and one is the selenium disulfide. So, this is not a typical disulfide SSE. One counterpart is sulfur, other counterpart is the selenium type. So, this is what is present in the thioredoxin reductase, which is involved in reducing the disulfide present in the thioredoxin, and this in turn is coupled with the protein activity, the protein disulfide bond breakage activity. Now, so this particular enzyme thioredoxin or and thioredoxin it has been divided in two classes. One is that present in a bacteria and eukaryotes, other is present in the animals. Both the classes are homodimer proteins. So, in these things, as we have seen, FAD, NADPH, like the other case, like the case of the mercury reductase, here also we have the cofactors. The cofactors of NADH at the end coupled with the FAD, which in turn will couple with the center for this purpose. So, FAD, NADH, NADPH and an active site, redox active disulfide, are present in both the monomers. So, these are in all these cases these are all dimers, but all these dimers function very well. Both the dimers will have a catalytic species. Now, let us look at the we have already looked at the glutathione peroxidase cycle. Let us look at the thioredoxin reductase cycle. Okay, see the enzyme here. So, in the native form you have a disulfide, you have a selenium sulfide cluster. Now, this is activated by NADPH as a step A, and that will activate to break down this bond between SC and S and give a open form of the SC and SH. And this is the activation step. So, this is the activation step. So, in the activation you have a NADPH involved. Okay, and this NADPH directly does not activate, goes via the FAD. Now, actual cycle starts because it has come into the active form of it. Second equivalent of the NADPH will break this side disulfide also, it is broken. And this now, so you have a SCSH broken down, SS broken down, and this will act on thioredoxin. Thioredoxin has got its own disulfide bond. So, therefore, this disulfide bond thioredoxin is the one which is activated by the kind of a complex we have with the thioredoxin part, and this in turn will reduce and give SH and correspondingly you have an oxidation part of it. So, which is coming over from here, and you also have SSE bond formed, and this one further with the activity of NADP NAFAD thing, then you can return back to the normal. So, here normal is already activated step, this particular step is already activated. So, therefore, that has broken the SES bond, and that is what you are seeing. Okay. And so, therefore, the loop goes this way rather than this way, you do not require. Once you activate the enzyme, it can continuously work unless there is some. Okay, thioredoxin reductase. Now, what did we do? We said the NAD, NADH, and then thioredoxin reductase, then redox, then going to the thioredoxin, then going to the protein, and that is what. So, let us look at. So, NADH gets oxidized and reduces the thioredoxin or that is reductase, the sulfhydryl function. So, this disulfide one will convert to the sulfide. So, what is this process? This is basically reduces. So, this one. Now, it is reduced, but it has not come into the catalytic cycle until you put into this. So, this is coupled with, because this one it gives this one, but this has to go back to this. So, to go back to this, and the enzyme thioredoxin or will use it disulfide selenium sulfide bond, and this selenium sulfide bond of this. So, with this process will break down. So, as a selenium and SH, and this is coupled with the SES bond connected in the thioredoxin. So, again this will come to the TRX SH2, and this particular reduced form will reduce the protein disulfide to protein thiol or protein cysteine. So, you see that this does not need to be activated by other things, and this part and this part, this part and this part, all of these are in connectivity. Now, we have seen glutathione peroxidase, we also have seen thioredoxin reductase. So, what did we study in this half an hour? We studied in this half an hour selenium is a micronutrient, but cannot be ignored. Just because there are no many enzymes which are bound like that of the metal ion, but we have a non-conventional way where the cysteine is converted to the selenocysteine. The micronutrient deficiency will give you problems, excess will give you toxic problems. So, and it is basically the selenium which is really working in the selenocysteine enzymes just by forming a disulfide kind of a bond or breakage, making a bond of SES or breaking this bond. So, formation and breakage. So, this is the main mantra for this particular entire enzyme. So, that is where the selenocysteine is working, and the glutathione peroxidase as I mentioned to you, which will act on the H2O2 and then make into water, and then I have talked to you that this is coupled with glutathione disulfide or oxidized glutathione. Then thioredoxin reductase OR is coupled with the thioredoxin, and thioredoxin reductase OR has got two SCS bond which will break and which will be transferred into the thioredoxin, and thioredoxin in turn will reduce the disulfide bonds in the proteins. Okay? And that is where the thioredoxin reductase, thioredoxin in this. So, thus we have seen an unconventional way of enzymes. Generally metalloenzymes are what? A metal ion and a lot of side chains of the proteins are attached, or the heme is attached, or a choline is attached. Here it is not like that. One of the amino acid itself is modified, a cysteine is modified to selenocysteine. So, therefore, nature can find variety of ways how it can survive, how it can combat with toxicities and other things too. The mercury reductase is also a toxicity reducing enzyme. Similarly, selenocysteines are also toxicity combating enzymes. Okay. So, this is which you call the glutathione peroxidase, and that is the mercury reductase. Both are toxicity combating enzymes. So, with this I conclude this selenium containing part. Thank you.